Hi everybody, good afternoon. Today we're going to discuss section 4.1 and 4.2. And in these two sections, in this chapter, we're discussing polynomials, okay? So to begin with, in section 4.1, the definition of the polynomial functions. We're talking about polynomial functions, that is, polynomial functions. We know what a polynomial is, okay? And polynomials are functions. So we have polynomial functions. Now, a polynomial function of degree n on page 263, section 4.1, polynomial functions of degree n looks like this. Polynomial functions of degree n. Okay? Here it is. Look, here it is. F of x equals to a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1 plus blah 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 all the way down to a sub 2 x squared plus a sub 1 x plus a sub 0. Okay, so this is a polynomial function of degree n. Note we're using the variable x. Okay, by this time we know what the degree is. We call this a polynomial function of degree n because the power of this variable is n. So this power, the greatest power is the degree. The greatest power is the degree of this function. Since this is n, and this is n minus 1, and it goes all the way down to, look at this, power is 2, power is 1, and then here, x to the 0. So this is of degree n. This is of degree. So let's give some examples. Examples. Here's a polynomial function, f of x equals to x squared. Okay. This is a polynomial function of degree 2. Look, power of 2. This is of degree 2. By the way, the leading coefficient is 1. There's a 1 there. But we don't have to show it. We don't have to show this 1. But it is understood that that's a 1. So this is degree 2. That's the power. And leading coefficient of 1. Okay, here's another one, another example. F of x equals to 5x plus 2. This is a polynomial function of degree what? Power degree 1. And what's the leading coefficient? 5. Another one. F of x equals to 7x squared plus 2x minus 9. Okay, so this is a polynomial function. What's the degree? Degree is 2. And what's the leading coefficient? Leading coefficient is 7. Very good. One more. F of x equals to negative 3x cubed plus 9. This is a polynomial function of degree 3. Degree is 3. And what's the leading coefficient? Negative 3. So these are polynomial functions. Note, the degree of the polynomial function is the greatest power. In this case, the greatest power is 2. That's the degree of 2. Greatest power is 1, degree of 1. The greatest power is 2, the degree is 2 for this polynomial function. The greatest power is 3, the degree is 3. Look at this leading coefficient. We call this number 7 the leading coefficient of this function. 7. The leading coefficient here is negative 3. Leading coefficient is 5. The leading coefficient is 1. Okay? Very good. You can have more. Okay, I'll give you one more. Let me call this one g of x. G of x equals to ax to the 5th minus 7x squared plus 2x minus 1. What's the degree? The degree for this polynomial function is degree of 5. There it is. What's the leading coefficient? 8. Very good. So these are polynomial functions. Now we are interested in the behavior of these polynomial functions. The end behavior. Yes, we are. We are interested in the end, the behavior to the right and the behavior to the left of the polynomial functions. We are interested in that because once we find out their end behavior, it's easier to graph polynomial functions. Okay? So I'm going to have to erase this, but I need the room. I need the room, so I'm going to have to erase this, okay? So here we go. I am erasing these functions because now let's look at their behavior. Okay? And let's take a look at this polynomial function right here, the easy one. This is the easy one. Look at this polynomial function. It's an easy one. We can graph it. We are really interested in the behavior of this polynomial function. Yes, we are. Okay? Let's graph it. Let's make a table. So here is x, and here is f of x. So when x is 0, 0 squared is 0. When x is 1, 1 squared is 1. When x is 2, 2 squared is 4. When x is 3, 3 squared is 9. When x is negative 1, what's negative 1 squared? 1. When x is negative 2, what's negative 2 squared? 4. When x is negative 3, what's negative 3 squared? 9. That's a 9, okay? 9. Let's graph this polynomial function. So here we go. X and f of x. Okay? So when x is 0, we get 0 right there. When x is 1, we get 1. When x is negative 1, we get 1. When x is 2, we get 1, 2, 3, 4. When x is 2, we get 4. When x is negative 2, we also get 4. When x is 3, we get 9. 4, 5, 6, 7, 8, 9. When x is 3, we get 9. When x is negative 3, we also get 9. Approximately there. And so. And so. Whoa. Okay, let me fix this a little bit. Came out crooked. There we go. Better. Okay. So this is a polynomial function of degree 2. Okay. Note also that at x equals 0, we have a minimum. Okay? At x equals 0, we have a minimum. And in fact, we're going to call it the absolute minimum. Why? Because there is no other minimum value or minimum point than this one. Okay? So therefore, at x equals to 0, f of 0 is a minimum value for this function. Okay? So, and by the way, there is no other minimum value or smaller value than this one. So we're going to call f of x equals 0. We're going to call it the absolute minimum. So f of 0 is the absolute minimum. Absolute minimum is the smallest value. Note that this goes up forever and ever, and this goes up forever and ever. Okay? So it seems to me that there is no absolute max. There is no absolute max for the entire function. Okay? All right. Let's look at the behavior, the end behavior. Note, degree is 2. Leading coefficient is positive. In fact, leading coefficient is 1. You see it? Positive. Look at the behavior of this function. Let's look at the behavior to the right. The behavior to the right. Note, it goes up forever and ever. So this function rises to the right. Look at that. It also rises to the left. Okay. So, this function is of degree even. 2 is even. And the behavior is it rises to the right and also rises to the left. Okay? And so therefore, if you graph another polynomial function with even degree, it's going to rise to the right. It's also going to rise to the left. And if you don't believe me, we can do another polynomial function of degree even. Watch this. So we have this already. Let's look at another one. Okay? Let's look at another polynomial function of even degree. Let's just change the degree. See this degree? I'm going to change it, but I'm going to keep it even. And I'm going to show you that the function, again, is going to rise to the right, and it's also going to rise to the left. I'm going to keep this degree even. And it's going to have the same behavior. Okay? Let's keep it even. I'm going to erase this. Well, maybe not. I'm going to show you something, okay? And I'm going to graph it in, let me see, graph it in blue. So I'm going to make this degree even, okay? Even. I already used 2. By the way, the degree can never be negative. If it's going to be polynomial, this degree, this power can never be negative. It's got to be positive. Because if this is negative, if the power is negative, or if the degree is negative, then we no longer have a polynomial function. In order for it to be a polynomial function, this power must be positive. So let's make this degree 4. And watch, it's going to have the same behavior. Okay, watch this. So if the degree is 4, when x equals 0, when x equals 0, was 0 to the 4th power? 0. When x equals 1, was 1 to the 4th power? 1. When x equals -1, was -1 to the 4th power? 1. If x equals 2, was 2 to the 4th power? 16. If x equals -2, was -2 to the 4th power? 16. If x equals 3, was 3 to the 4th power? 81. If x equals -3, was -3 to the 4th power? 81. I'm going to graph it. I'm trying to show you that because the degree is even and the leading coefficient is positive, this is going to rise to the right and it's going to rise to the left. Okay? Whenever the degree is even and the leading coefficient positive, it rises to the right and it's going to rise to the left. Okay. So let's graph it. Watch this. 0, 0. Right here. 1, 1. 1, 1 right there. -1, 1. -1, 1 right there. Okay. 2, 16. 2, 16, way up here. I'm going to say 16 is way up here. -2, 16. Okay? So this is the behavior. That's it. Note. That's the behavior. Degree is even, leading coefficient positive. What's the behavior? It rises to the right and rises to the left. That's the behavior. Okay. Now, we can state a property. The property should say that whenever we have a polynomial function and the degree is even and the leading coefficient is positive, it's going to rise to the right and it's going to rise to the left. Okay? And that should be on one of these pages. Yep, it should be somewhere. I don't know where it is. Okay. All right. Yes, it's on page 278. Okay. On page 278, at the bottom, page 278, the bottom, it has this information, okay? Okay. Watch what happens when we change the leading coefficient. I'm going to keep the degree even, but I'm going to change now the leading coefficient. The leading coefficient, I'm going to make it negative. Okay, watch what happens. Okay, I'm gonna change this f of x, and I'm gonna use a different color, and I'm gonna use this, I'm gonna put a negative in front, right there. So now we have f of x equals negative x to the fourth. Watch what happens. When x is 0 right there, 0 to the fourth is 0. So the answer is 0. Let me erase this, okay? You already have this, okay? So let me erase this, and I'm going to show you what's going on. So when x is 0, 0 to the fourth is 0, and then negative 0 is just 0. If x is 1, note the 1 is being raised to the fourth power, okay? Not the negative. This negative is not raised to the fourth power. Only whatever x is. So 1 is raised to the fourth power. What's 1 to the fourth power? 1. But then this negative in front of it. If x is 2, 2 is raised to the fourth power, okay? 2, just the 2, not the negative. This negative is independent. So the 2 is raised to the fourth power. It's like this, look. There's a negative there, and then the 2, only the 2 is raised to the fourth power. Watch this. Only this 2 is raised to the fourth power. What's 2 to the fourth power? 16. But this negative remains there because the negative is not being raised to the fourth power. So therefore, this is negative 16. Let's do negative 1. Okay, let's do that. Let's do it again. This negative 1, according to this expression, the negative 1 is going to be raised to the fourth power. Okay, this is the value x, and that's raised to the fourth power, but there's a negative in front. Look, negative in front. So what's raised to the fourth power? This negative. And what's negative 1 to the fourth power? 1. But then there's this negative in front. So this is negative 1. Okay. Let's do another one. One more. Let's plug in negative 2. I ask you, what's going to be raised to the fourth power according to this? What is going to be raised to the fourth power? The negative 2 is going to be raised to the fourth power, but according to this function, there's a negative in front. This negative, which is right there, is not being raised to the fourth power, okay? Don't forget that. So what's negative 2 to the fourth power? 16. But there's this negative in front. So we get negative 16. You see? Okay, very good. Let's graph it. I think we have enough. Okay. Graphing it. 0, 0. Right there. 1, negative 1. 1, negative 1 right there. Negative 1, negative 1. There. Okay. 2, negative 16. 2, negative 16 way down here. Negative 2, negative 16 way down here. So therefore, this function looks like this. That's what it looks like. So look, I just showed you that when the leading coefficient is even, when the degree is even and the leading coefficient is negative, it falls to the right. You see it? It falls, goes down. So down to the right, falls to the right, and also falls to the left. That's the behavior. Okay? So therefore, on page 278, you read the concept of the end behavior of polynomial functions. Okay? The end behavior. Let me say it one time. If the degree is even and the leading coefficient positive, what's the behavior to the right? I ask you. Rises to the right. What's the behavior to the left? It rises to the left. That's the end behavior when the degree is even, the leading coefficient positive. If the degree is even and the leading coefficient negative, this one, degree even, leading coefficient negative, it falls to the right, that's the end behavior, and it falls to the left. Okay? Very good. Okay. Let's try degree odd. Okay? Now we're going to try degree odd. Okay? What is an odd degree? Okay. Let's try degree odd, and let's keep the leading coefficient positive. Degree odd. That's odd. Leading coefficient positive. Let's make it a 1, a positive 1. You know that when the leading coefficient is 1, you don't have to show it. There you go. Okay. All right. Let's make a table. Table x and f of x. Let x be 0. What is 0 to the third power? 0. Let x be 1. What is 1 to the third power? 1. How about 2? Let x be 2. What is 2 to the third power? 8. Let x be 3. What is 3 to the third power? 27. Let x be negative 1. What's negative 1 to the third power? What's negative 1 to the third power? Negative 1. Yep. What's negative 2 to the third power? Negative 2 to the third power? Negative 8. What's negative 3? Negative 3 to the third power? Negative 27. This is a table for this function, which is of degree odd, leading coefficient positive. Degree odd, leading coefficient positive. We're going to look at the end behavior, okay? Degree odd. leading coefficient positive. Okay, let's graph it. Graphing it. Okay. 0, 0. There you go. 1, 1. There you go. 2, 8. 2, 3, 2, 3, 4, 5, 6, 7, 8. 2, 8. Negative 2, 8. Well, let's try negative 1, negative 1. Negative 2, negative 8. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. Negative 2, negative 8. So that's, and then we have 3, 27 way up there. Okay, so I don't have enough room. So we have this. Whoa. Try this again. And this way. That's the behavior. Look at that. Okay. Degree odd, leading coefficient positive. What's the behavior? Rises to the right. False left. False left, rises to the right. That's the behavior when the degree is odd, leading coefficient positive. Okay. All right. We also say this function is odd. This is an odd function. Okay, so we have even functions. We also have odd functions. Okay, I'm going to go back and I'm going to explain to you what an even function is in a few seconds. But we call this an odd function. Okay, the end behavior, it rises to the right, falls to the left, when the degree is odd and the leading coefficient is positive. Okay? So we are learning the behavior of polynomial functions by looking at their degrees and their leading coefficients. That's what we're trying to learn right now. Okay? So don't forget this. Listen, guys. The moment I put a negative in front, if I want to graph another function with a negative in front, the leading coefficient negative and the degree odd, the behavior is going to change. Okay? We can do that. Watch this. How about if I want to graph the following? How about if I want to graph g of x equals 2, I'm going to put a negative x to the third. What do you think the behavior is going to be? You can make a table. Note, degree is odd, leading coefficient negative. What do you think the end behavior is going to be? Well, the end behavior is going to be the following. It's going to fall to the right, and it's going to rise to the left. And if you don't believe me, let's make a table. When x is 0, we get 0. When x is 1, what's g of 1? Negative 1. When x is 2, what's g of 2? Negative 8. When x is 3, what's g of 3? Negative 27. If x is negative 1, what's g of negative 1? Let's write this down, okay? There's a negative right there. And then x is negative 1. And then negative 1 is being cubed. So here the negative 1 is cubed first. What's negative 1 cubed? Negative 1 cubed is negative 1. So this is negative 1. But then there's this negative right in front of it. Note, I just cubed negative 1. Cube is negative 1. But let's not forget about this negative there. And what's a negative times a negative? 1. So when x is negative 1, we get 1. Let's do one more. How about if x is negative 2? Well, that's going to be negative times negative 2 to the third. So cube negative 2, which is, what's negative 2 cubed? That's negative 8. Let's not forget about this negative. This negative here is not being cubed, okay? Just this negative 2 is being cubed. So this negative remains. So what's negative times negative? 8. I think we have enough to graph. 0, 0, look. 1, negative 1. 2, negative 8. 2, and then 1, 2, 3, 4, 5, 6, 7, 8. 2, negative 8 right there. Look. Negative 1, 1. Negative 1, 1, look. Negative 2, positive 8. Look what happened, guys. Look at that. Okay. So this is g of x. And this is f of x. Look at g of x. G of x, degree is odd, the leading coefficient negative. Degree odd, leading coefficient negative, right here. Look at the behavior. What's the behavior? It falls to the right, rises to the left. The opposite of this? Let's write that down. Falls, write it in blue, okay? Write it in blue. Falls, right, rises, left. Yep. Okay, so now you have enough to be able to read section 4.2, page 278, the behavior of polynomial functions, the end behavior. Okay? What is the end behavior, guys? If the degree is odd, the leading coefficient positive. Degree odd, leading coefficient positive. it rises right, falls left. That's the end behavior. What is the end behavior if the degree is even? Degree even, leading coefficient negative. Falls right and falls left. The end behavior, guys, the end behavior. We're looking at the end behavior, okay? So right now we have enough. We have enough to find out the end behavior. Okay, guys? So, let me give you an example. I'm just gonna look at the end behavior, okay? The end behavior. Okay. Now, why do we want to know the end behavior? Because if you know the end behavior of the function, it's going to be easier to graph. So you want to find out, you want to have an idea of what the function is going to behave before you start graphing. It's going to make it easier to graph. So watch this. F of x equals to negative 5x to the third plus 2x. What is the end behavior of this function? Well, the end behavior, we first must look at the degree and the leading coefficient. Degree is 3 odd. Leading coefficient is negative 5 negative. So what's the behavior of this function? The end behavior? Well, let me see. This function is gonna fall to the right and it's going to rise to the left. That's a good thing. Okay, it's a good thing. So watch this. If it falls to the right and rises to the left, it means that we have an idea what it looks like. Okay? So once we have an idea what it looks like, it's easier to graph. This function is going to fall to the right and rise left. And now this function, the question is this function odd or even? Okay? All right, but first let's try to graph it. Then I'm going to show you how to check to see if the function is odd or even. Okay? So this function falls to the right, rises left. We can find the zeros. We can find the zeros, which are the X-intercepts. Find the X-intercepts. Also called zeros. How do you find the X-intercepts? let f of x equal 0. 0 equals to negative 5x to the third plus 2x. Okay. Let's solve this equation. 0 equals to, let's factor out an x. X times negative 5, right? X squared plus 2. You can also factor out a negative. Okay, let's take out a negative x. How's that? Take out a negative x. Negative here. And negative there. Let's check, okay? Let's check. Negative x times 5x squared is negative 5x cubed. Got it. And a negative times a negative is positive. So negative x times negative 2 is positive 2x. So this is the factor form of the original expression. Okay? And now we're going to solve. To solve this, you make this first factor equal to 0. So to solve, negative x equals 0 or 5x squared minus 2 equals 0. If negative x equals 0, what is x? X equals 0 or 5x squared equals 2. X equals 0 or x squared equals 2/5. X equals 0 or x equals plus minus the square root of 2/5. Take the square root of both sides. That's a number. Okay, that's a number. Let me show you what it is. If I can get this. Let me see. I thought I had. Oh boy, I don't have it. Okay. My calculator's not here. Okay, we're going to show you what this number is. Did I erase my calculator? I think I did. Okay. Oh, there it is. Okay. So, take there it is. So 2 divided by 5 equals, and now take the square root of that, and I get the following. So this x equals plus minus the square root of 2/5, which is 0.6, and I'm going to round to the nearest hundredth. Look, we know that the degree is odd and the leading coefficient negative. Degree odd, leading coefficient negative. That means that this function is going to fall to the right. It's going to rise to the left. We also found the zeros. Look, at x equals 0 and at x equals to positive negative 0.63. Okay, watch this. We're gonna graph. This is x, and this is f of x, which equals to negative 5x cubed plus 2x. Okay, all right. So when x equals 0, the function is 0. When x equals to 0.63, the function is 0. Okay, so this is 1. This is 0.63. I'm going to say this is 0.63. Okay. When x equals negative 0.63, the function is 0. This is negative 1, and this is negative 0.63. Okay. You know that the function falls to the right, rises left. And you can verify that, okay? All right, very good. So now we found the X-intercepts, which we call the zeros. Okay, very good. All right, because we know the end behavior to the right is it falls. And we also know that we have an X-intercept at 0.63. So it's going to cross the X-intercept there, and because we know the end behavior, it's going to do this, guys. We know that. It's going to cross at 0.63. It's going to cross at 0.63. It's going to go up, and then it has to come down and cross back at x equals 0. It has to. It's going to cross at x equals 0, and we'll talk about this more, okay? Later on, I will show you why I know it's going to cross and not touch. It's going to cross. It has to do with the power of it, the factors, okay? But we'll talk about that later. It's going to cross at x equals 0. It's got to come back up and then cross again at 0.63, negative. And then the end behavior to the left is it rises to the left. And there we go. Guys, so my point is that when graphing polynomial functions, it pays to know the end behavior of the function. It also pays to know if the function is odd or even, okay? It seems to me that this function is odd, which the concept of odd, it means is symmetric with respect to the origin. What does that mean? Well, it means symmetric with respect to the origin. It means that the function to the right of the x-axis behaves in the opposite direction of the left, of the y-axis. Okay, let me say that again. What does it mean to be symmetric with respect to the origin? It means that the function repeats itself in the opposite direction across the y-axis. Like this one, look. You see this? Look at this. Look at the behavior to the right of the y-axis. It goes up, then it comes down. Well, if it repeats itself in the opposite direction to the left of the y-axis in the opposite direction, then it's going to be symmetric with respect to the origin. And it does. because this function goes here, look, it goes up to the right and then it comes down at 0.63. Well, guess what? On the left, it goes down in the opposite direction. It goes down and it comes back up at negative 0.63. So it is repeating itself. It is repeating itself in the opposite direction to the left of the y-axis. That's what it means to be symmetric. It repeats itself in the opposite direction, okay? But with respect to the y-axis. With respect to the y-axis, okay? So this function is symmetric with respect to the origin in the opposite direction. That's what it means to be an odd function. This function is odd, okay? This function is odd because it repeats itself in the opposite direction with respect to the y-axis. Okay? And there's a way to find out if the function is odd. Gotta erase this, okay? Don't forget, this is 0.63 and this is negative 0.63 right there. So this function is repeating itself. Look at this, 0.63, negative 0.63, okay? We have to talk about these values later, okay? This minimum, this is a maximum, local maximum and local min. We'll have to talk about that later, not now. All right, let me show you how to check to see if a function is odd. When the function is odd, it means it is symmetric with respect to the origin. Okay. How do we check to see if this function is odd? How do we check? How to check for an odd function. Here's what we do. If f of negative x equals to negative f of x, then f of x is odd. If someone asks you, what is an odd function? Your answer should be, odd functions are symmetric with respect to the origin. But what does that mean? It means, guys, that if you go to the origin, if you look at the y-axis, the origin is on the y-axis, okay? To be odd, it means that on the right of the y-axis is the opposite, okay, of the left. Exactly the opposite. They behave in the opposite directions with respect, they say, to the origin. Okay? We have to check for this. How do we check for this? This says you're going to plug in negative x into the function. So let's plug in negative x into this f of x. Negative x, I'm going to plug it into f of x. So this is negative 5 times negative x. I'm going to plug in negative x for x, okay? To the third plus 2 times negative x. We're trying to see if this function is odd. If f of negative x gives you negative f of x, then the function is odd. Okay, so here we go. Negative 5. Anybody knows what negative x to the third is? What's negative x to the third? Negative x to the third is negative x. What's 2 times negative x? Negative 2x. What's a negative times a negative? Okay, so negative x to the third is negative. If you raise this negative x to the third, it's gonna be negative x. Let me select this. Look, negative x to the third is negative x times negative x times negative x. Okay, I'm gonna explain to you how we get the following. Okay, what's a negative times a negative times a negative? A negative times negative times negative is negative. And what's x times x times x? Don't forget, this is negative, is negative 1 times negative 1 times negative 1, that's negative 1. And what's x times x times x? X to the third. So therefore, this equals to negative x to the third. Okay, so therefore, well, let me leave it there. What's negative x to the third? Right there. Negative x to the third. Okay. And what's a negative times a negative? Equals 5x to the third minus 2x. Now you factor out a negative because we want to know if this is the opposite of the function. So let's take out a negative. Negative times what gives you positive? Negative 5x to the third plus 2x. And what is this, guys? It's not the function itself. Look, it's the function itself. So this is negative f of x. Okay. When we graph the function, it did look symmetric with respect to the origin. It looks odd. We had just proved that it is odd. Why? Because we just proved that f of negative x equals to negative f of x. F of negative x equals to negative f of x. There it is. This function is odd. What does that mean? It means to the right of the y-axis is the opposite of the left of the y-axis. That's what it means to be symmetric. Okay, that's what it means to be odd. All right. So, guys, if you ever have a function that repeats itself in the opposite direction with respect to the y-axis, you call it odd. If you have a function that repeats itself to the right of the y-axis, it repeats itself, not in the opposite direction, okay? We call it even. What am I talking about? Okay, so this function is odd. This function is odd. And this is what you do to show that a function is odd. Okay? Almost done, okay? Almost done. Consider the following. Consider this. F of x equals 2x to the fourth plus or minus x squared. What's the degree? What's the degree for this? It's 4. Even. What's the leading coefficient? The leading coefficient is 2. Positive. Okay. So what's going to be the end behavior? This function is going to rise to the right and rise to the left. Now, is this function even? The question is the function even? We can check for that. What does it mean to be even? It means that on the left of the y-axis and on the right of the y-axis, it's going to be exactly the same. It's going to repeat itself on the left and the right of the y-axis. This one is odd. It repeats itself in the opposite direction. Notice, goes this way, and then here goes up. It repeats itself, okay, in the opposite direction. This one, we want to find out, we already know its end behavior. What is its end behavior? Rises, right, rises, left. Up to the right, up to the left. That's its end behavior. Question, is this function even? That's the question. It's not odd. I know that already, because it's not gonna repeat itself in the opposite direction to from the y-axis. It's not gonna be in the opposite direction. I know that. Okay. How do we check to see if this function is even? I know it's not odd. Question, is it even? Here's what we do. If f of negative x equals to the same thing again, then if this is equal to the f of x again, then function is even. And what does that mean? What does it mean to be even? Watch this. I'm going to make for you an even function. If the function does this, an even function is going to repeat itself on the left-hand side of the y-axis. It's going to repeat itself exactly the same. I'm just going to repeat this. That's an even function. This is even. Okay. And our function, it repeats itself in the opposite direction. Odd. Explain to you what an odd function is. Okay, let's do this. For an odd function. Okay, that's the function right there. If I want to make it odd, I got to repeat the same thing, but in the opposite direction. Okay. That's the opposite direction. There it is. This is odd. How do you check for odd? F of negative x, you plug in negative x into the function, and you better get the opposite, negative f of x. How do you check for even? You plug in negative x into the function. So you plug in negative x into the function and you're going to get the same thing. Yes, the same thing. You get f of x. Even. Odd. Okay. This one is odd. Okay. How about this one? Is this even or is this odd? Okay. Well, you can plug in negative, let's plug in negative x into the function. See what happens. Okay, so let me erase this. Gotta erase this, guys, okay? Gotta erase this. All right, I'm gonna plug in negative x. So f of negative x into the function. If I get the opposite of the function, then it's odd. If I get the function again, then it's even. If it's even, I graph one side to the y-axis, and I know it's going to be exactly the same thing on the left side. That's what it means to be even. Okay. Plug in negative x into the function. 2 times negative x to the 4th power minus negative x to the 2nd power. Anybody knows what negative x to the 4th power is? This is 2 times x to the 4th minus. Anybody knows what negative x to the 2nd power is? X squared. Did we get the same thing? Yes, we did. Look. Plugged in negative x into the function. I got this, which is the same thing as the original function. So it is f of x. So now I know this is even. So because it's even, I know that to the right of the y-axis is going to behave the same way as to the left of the y-axis. So here we go. Let's graph it. This is the last example, okay? Graphing it. What's the behavior? Right is right, right is left. Let's find intercepts. Let's find the x-intercepts. We can find x-intercepts here. Yes, we can. So we just found out that this is even. Yes, it is. It's even. All right. Now let's find out the intercepts. The x-intercepts. What's another name for the x-intercepts? The zeros. How do you find the x-intercept? Let f of x equal 0. 0 equals to 2x to the fourth minus x squared. Don't forget, we know it's n behavior. Rises right, rises left. 0 equals to, factor out an x squared. X squared times 2x squared minus 1. Let's check. X squared times 2x squared is 2x to the fourth. X squared times negative 1 is negative x squared. Okay. X squared. Oh, let's set the first one, let's set the first factor equal to 0 and the second factor equal to 0, okay? Okay, yes, let's do that. So x squared equals 0, and also 2x squared minus 1 equals 0, and this is OR. If x squared equals 0, x equals to 0. This is 2x squared equals to 1, x equals to 0, and this is x squared equals to a half, x equals 0, and this is x equals to plus minus the square root of 1/2. Okay, if you want to, go ahead and take the square root of 1/2, so 0.5, and take the square root of that right there, and I get 0.71. So this is x equals to plus minus 0.71, and this is x equals 0, and this is or, that means or, that means or. We know it's n behavior. Yes, we do. It rises right. It rises left. We know it's even, which means to the right of the y-axis is going to repeat itself. Okay? The function, the graph to the right is going to be the same as the graph to the left from the y-axis. I don't know if I'm saying it right, okay? It repeats itself across the y-axis. That's what it means. It repeats itself across the y-axis. That's what it means to be even. Okay? By the way, when the factor has a repeated, how can I say this? Okay, we'll talk about this later. Okay, because I have to go back and read it before I say anything. But I know I'm just going to tell you this. I know that it's going to touch at x equals 0 because of the power is right here. This power, it's going to touch at x equals 0, and there's a term for it. I just forgot the term. Okay, and it's going to cross at x equals 0.71, positive and negative. Okay, so therefore, watch this. At x equals 0, we get 0. Okay, at x equals 0.71, we get 0. At x equals negative 0.71, we get 0. So what's going to happen? You can plug in, watch this. You can plug in x equals 1 into the function. Watch what happens when you plug in x equals 1. What's 1 to the fourth? 1. What's 1 times 2? 2. What's 2 minus 1? 1. So at x equals 1, we get 1. By symmetry across the y-axis. Okay, that's what it means to be symmetric across the y-axis. when x equals -1, you're also gonna get 1. You see, because it is even. Hey, see, I'm using all this information to graph. So that means that the function is gonna go down, it's gonna come up, pass through the 0.71, it's gonna go up and pass through this and go up, rises to the right. Okay, the multiplicity, that's the term, the multiplicity, okay? Whenever the multiplicity is even, it touches. If the multiplicity is odd, it crosses. We'll talk about that later. Okay, so this goes, okay, so this, it touches there, comes back down, and it's gonna repeat this, it's gonna repeat itself again across the y-axis because it is even. So it's gonna do exactly the same thing as this. It's gonna go down, and then come back up, and then do this. So we're using all this information, guys. We're using all this information, okay? All right, this was section 4.1, 4.2, okay? 4.1 and 4.2, all right? And the graphing part is in section 4.4. Guys, so now you can graph, you can do, guys, section 4.1, 4.1, 4.2, and 4.4. Everybody, all right? You could do these 3 sections, 4.1, 4.2, and 4.4. Okay, good class? Take care. Stay away from trouble. Okay? And we'll see you soon. All right? Bye.